I will go. I will talk about t-test also. This is very important lecture. Please listen very carefully. If you have question, you can ask. Um, I think the screen is visible to all of you. If not, please tell me. Sorry, my mouse is not working. Please give me 1 minute. Okay, let's start the lecture. So throughout of this lecture, I'm going to talk about t-test. So this is my outline. Normally, throughout of the lecture, I
Hello?
will.
Miss,
Yes.
it is not being shared, no?
Ah,
It is
okay.
not.
Wait. Now, can you see?
Can see.
Ah, okay. Sorry for the inconvenience. So, introduction to t-test. This is my outline. I will explain you when to use the t-test, what types of t-test you should use, and how to perform t-test, how to interpret results, and how to present your results, and what are the common questions that we go through when you are running t-test, right? So, t-test. Uh, Normally, we use t-test to compare means of two groups. That is the simple way that I can explain you why you use t-test. Normally, you use t-test to compare means of two groups. Uh, there is three types: one sample t-test, two sample t-test, and pair sample t-test. But before you go for t-test, you have to complete these assumptions. Always after you collected your data, you should check whether your data are independent. That means your data need to behave independently. There shouldn't be any correlations with any other, right? And also they should behave normally, normal distributed way, and have similar amount of variance within each group being compared. That means all the data you obtain should have similar variance, right? If these three assumptions don't complete, you can't go for t-test. Then you have to go for non-parametric test, right? If your data don't behave normally, you have to go for non-parametric test. The equal test for the t-test in non-parametric we call Wilcoxon sign rank test. Just keep the name in your mind, uh, and always before running the t-test, you need to check whether your data are independent, whether they behave normally, normal way, and the variance of all the data should be equal in the both groups, both samples you used, right? So I told you that there are three types of t-test: one sample t-test, two sample t-test, and paired sample t-test. So let's move to one sample t-test. What is one sample t-test? We use the one sample t-test to test the mean of single group against non-mean. Normally, in one sample t-test, you have only one sample, one group of sample, right? For example, you want to compare a mean weight of mice, rats. Here, you need to check one parameter. That means for here the researcher has need to check whether the mice The weight of a mice is differ from a mean value of 200 milligrams, whether it is equal to 200 or less than or greater than. From one experiment has done, and from that experiment someone has identified the mean weight of a mice is 200, right? So the new researcher have wanted to check check it whether this is true or not, whether his sample, the sample of his weight of his mice will be same as 200 or whether it is less than or more than that. I will go for more example in next slides. Don't get panic. First thing you need to, I told you in my first two second slide also, before you run the t-test, you have to think about all these assumptions. First thing is test a variable that is continuous. Always the variables that you are going to test should be continuous. For example, if you are going to check the weight of an apple, so the always the value should come as continuous, so interval or ratios manner, right? It shouldn't be a categorical. If your data comes as categorical, you can't run t-test. Always, other thing is score on the test variable are independent. That means there is no relationship between scores on the test variable, and always the random samples of data from the population. So you should take your sampling should be done randomly, and it should behave normally, right? So all these assumptions should be completed before running one sample t-test. So in one sample t-test, you have to write hypothesis this way. I told you we use statistical test to check the hypothesis, right? So here I will explain you how to write hypothesis for one sample t-test. Hypothesis. The null hypothesis we indicate as H naught, and the alternative H1 here. Here the null hypothesis. Here, mu is population mean, MS is sample mean. Here, the sample mean is equal to the population mean. That is the H naught, and the alternative is opposite of that. The sample mean is not equal to population mean. So you are going to test this hypothesis using one sample test, right? Uh, this is the formulas that if you try to calculate by hand, right? The test statistic for one sample t-test is denoted T. This is T value, which is calculated using following formula. T here S bar is mean, and the mu is population mean, sample mean, and the population means it is divided by estimated error of the mean. Is uh, so from this formula, you can see how the estimated error or standard error is calculated. S is standard deviation, and it has been divided by root of sample size A. These two formulas will be used if you are trying to calculate by hand, right? The calculated t after you calculated the calculated t value is then compared to the critical t value from the t distribution table. I think you have already heard about t distribution table. You need to compare t table, right? After calculating your value, your calculated value should be compared with the value in your t table. If the calculated value t, the value you obtain t, is more or greater than the critical value t, the value in t table, then you have to reject the null hypothesis. This one. You have to reject null hypothesis. That means you have to accept the alternative hypothesis, right? Example. This is my problem statement. According to CDC, the mean height of adult age 20 and older is about 60.5 inches. For males, it is 63 point inches, 69.3 for males and 63.8 for females, right? Let's test if the mean height of one sample data is significantly differ than 66.5 inch using one sample test. Here, the researcher want to test whether the mean height of our sample, the sample of this, sample data is significantly different than 66.5 using the one sample test. So you can, first thing you need to do is you need to write your hypothesis, alternative and null and alternative. Here the 66.5 equal to population mean. Population mean of mean, right? The mean height of the sample is equal to 66.5. 66.5 is population mean, sample mean. So you need to say that the sample mean is equal to population mean. The H1 or alternative hypothesis is always opposite of this, it is differs. So you need to run one sample t-test to find out whether the whether this is equal or not equal, right? So the this is SPSS output. There I have run the one sample t-test, and so this is the output. In SPSS output, you will get two sections, one sample statistic and one sample test. The first section, this section, here you can see height, the sample size is 408, the mean value is 68.01, standard deviation and standard error mean. You have obtained, you can get these results using running the one sample t-test. Here one sample t-test in SPSS. For that example, here you can see the first section is this table you will get after you run the SPSS. One sample statistic provide basic information about the selected variable. Here selected variable height, including sample size, mean, standard deviation, standard, all the descriptive variables about height, right, of your sample. The second output is this. The second section, one sample test, display results most relevant to one sample t-test, right? These are the second table you will get. You have to interpret this result. First, be familiar with this test value. 6.65, that is the sample mean, right? A is test value. The number we entered as the test value is one sample t-test window, right? This is the test value that we are going to test, 6.65. And the B, here B is t statistic or t value. That this is the t value that you did previously hand calculation. If you run SPSS, you don't need to run hand calculation, automatically you will get t value. This is that t value, the test statistic of one sample t test denoted t. In this example, t is 5.18, right? Note that t is calculated by dividing the mean difference of standard error mean. And C. Here C is degrees of freedom. For one sample t-test, degrees of freedom, normally we take degrees of freedom in -1. So here sample size is 408, so -1, 407. That is degrees of freedom for this sample. And D is significant. Whether it's two-tailed or one-tailed, this is the probability value. Here, the two-tailed p-value corresponding to the test statistic. And E. This E is, I explain you that this is the confidence interval that it has automatically generated. You have just entered 95% confidence level. For this, the confidence interval upper limit and lower limit is this, right? So the difference between observed sample mean and the expected mean. The sign of mean difference corresponds to a sign of t-value and the confidence interval. Okay, the decision is this probability is less than 0.01, because here the two-tailed value is here 0.00, right? This is the probability value we obtain. If your probability value is less than 0.01, we reject null hypothesis that the sample mean is equal to the hypothesized population mean. Uh, at the beginning, I told you that you need to write your hypothesis. The mean of height sample is equal to population mean, right? This one. But after the calculation, you have received that probability value is 0.00. So it is less than 0.01. So if it is less than the 0.01, you have to reject your null hypothesis. Then if you reject your null hypothesis, that means you have to accept or go for alternative hypothesis. That means the mean height of sample is not equal to 66.5. So finally, you have to do conclusion this way. The positive t-value in this example indicates that mean height of sample is greater than the hypothesized values, right? 6.65. So the confidence interval for the difference between the specified test value and the sample mean. If is confidence interval for the difference, just forget about it. So your conclusion should be this way. Based on the results, we can state that there is significant difference in mean height between sample and the overall population. So mean of the height of sample and the mean height of the population is not equal. It is difference, and the average height of sample is about 1.5 inches taller than the overall adult population average. That means this. So you can here the difference between difference is 1.5, right? So always the average height of sample is 1.5 inches taller. The sample mean is 1.5 taller than the adult population in average. So you can simply come to the conclusion that the population mean sample mean is not equal to the population mean, right? That is one sample t-test. Normally in one sample t-test, always you go to use one sample, right, and you need to check or compare averages, right? Here in that example also you did comparison whether the population mean of the sample and mean of the population equal or not. So that is how you run one sample t-test, right? So the second one is two sample t-test or independent sample t-test. This is the one that most of us go familiar with, because in our day most of researchers use this t-test. There are several names, similar names for this: independent special t-test. Normally, two sample t-test, independent sample t-test, student t-test. Those are the similar name for this t-test. Before you run this t-test, you need to know these names. The variables used in test are known as dependent variable. Normally, you after you calculated or after you completed writing your questionnaire, you need to identify what are your variables, whether they are dependent variable or independent variables. Normally, dependent variables we call test variable or outcome variable. Independent variable we call grouping variable or predictor variables. And so here, to compare the means of two independent, normally you use this two sample t-test to compare the means of two independent groups. Uh, if you need to find out statistical difference between the means of two groups, you go for two sample t-test. Also, if you want to find statistical difference between means of two interventions, so for example, you are conducting a research to check whether the practical skill of nursing students before and after. So first, before you did any awareness program, before you conducting awareness program, you want to get their knowledge level, right? So you collect data to find out their knowledge level at the beginning. After that, you are going to do any intervention, whether you are going to make them aware about any topic, right? After that, you are going to check whether their knowledge has been upgraded. So you give second questions, and second time also you distribute question and collect their data, and you can get results second time also. So after intervention, before intervention and after intervention, you will collect your data, and you want to check whether there is any improvement from before and after of the intervention, right? In that case also you have to go for t-test. And also statistical difference between means of two change scores. If you are changing any scores, you want to find out whether there is any difference, mean difference of scores also. For example, here I have given one example. You might want to compare average weight of individual groups by gender, male and female, which are two unrelated individual. So you want to here you want to check the average weight is difference according to the male or according to the gender, whether male or female have any difference of their weight of mean weight, right? So here Male and female are independent groups. Two groups I have selected. So I am going to compare mean weight of two groups. So in that case, in this example, I need to go for two sample case. Normally, to conduct two sample t-tests also, you need to complete these assumptions. First, your dependent variable is continuous. The dependent variable is your predictive variable, and it must be continuous, so numerical value, right? It must be in the form of numerical value, and your independent variable should be in categorical form. For example, male female in my first example, the your predictor independent variable, that is, it must be in categorical way. So two or more groups. Here predictor variable should be categorical, outcome variable or dependent variable should be always quantitative, right? Uh, Cases that have values on both dependent and independent variable, always just forget about this line. It is an independent sample. It should be, the sample should behave independently and randomization should be there, and also the data should behave normally. If all these assumptions can be completed, you can go for two sample t-test. This is the how you are going to write hypothesis for uh, this two sample test, right? And the null hypothesis and alternative hypothesis of independent sample t-test can be expressed in two different ways. First, but both are similar, right? It's not mu1, mu2. The two populations means are you equal. The null hypothesis is you can write this way. The two samples, population samples means are equal. The opposite of that is population means are not equal. Or in other way, you can write that this way. Mu1 minus mu2 equals 0. The difference between two population means equal to 0. This is similar to this one, right? If you take this mu2 into this side, it will be like this same. You mu1 equal mu2. So you can write either this way or this way. So how to do hand calculation? So you can use these two formulas to do hand calculation. Here the S1 is mean of first sample, S2 is mean of second sample, N1 is first sample, sample size, N2 is second sample size, S1 is standard deviation of first sample, S2 is standard deviation of second sample, full SP is full standard deviation, right? This is the formula that you need to use to do hand calculation if you go for two sample case, right? So I will give you one example and a problem statement. In our sample data sets, student reported their typical time to run a mile, and whether or not they were an athlete. According to athlete or non-athlete, they want to find out run time, right? Suppose we want to know if the average time or time to run a mile is different for athlete versus non-athletic. For example, we are going to find out whether the average time for the time of running is different for athletes or non-athletes. So that is the thing that we are going to find out, right? Here, this involve testing whether the sample means for mile time among athlete non-athlete in your sample is statistically different. You can use an independent sample t-test to compare this, because there is two samples. One sample is athletes, others are non-athletes, right? This is how I'm going to write the hypothesis. First one is non-athletic and athletic. The mean running time of athletic and non-athletic equal to 0 or not equal to 0. This is the first thing I did before running the test. So I wrote the hypothesis, null and alternative. And there are three variables. In the sample data, we will use two variables. First one is athletic, and this is the running time. Right? Type of athletic, whether non-athletes we call 0, athletic we coded as 1. Here, and they are running time. So we enter this way into the SPSS. Right? After that, you have to run the test. After running the test, uh, you will get the interpretation this way. First, first you will get descriptive statistic of the test. Here the number of non-athletes is 226. Their mean is this one, and the athlete is this way. Right? Uh, the mean mile time for athletics is 6 minutes and 51 seconds, and the non-athlete is 9 minutes and 6 seconds. And the second table, the second section, independent sample details, display the disease out of species. Displays the results most relevant to the independent sample details. There are two parts that provide different pieces of information. So to this, equals variance assumes, equals equal variance not assumes. Normally, you have to go for here if your the significance value is less than 0.001, you have to go for equal variance, not assume row, right? So here you are going to interpret your results using this row. Here the t-test value is 15.047, and the significance is less than 0.01, and the mean difference, the difference between running time of athlete and non-athlete is 0.02. And here also you can see the confidence interval is this one. Let me interpret this. Here the B. B is the t-test for equality of means provide results for actual independent sample t-test from left to right. T is the computer, t-state, D degrees of freedom. Here, this is the t statistic, this is degrees of freedom, this is the probability value, this is the difference between athlete and non-athlete running time, this is the confidence interval. That is the things explained by this slide. These are the things, and this is the conclusion. Since P, the probability value is less than 0.01, because here the probability value is less than 0.001, right? So you have to conclude this way. Since p value is less than 0.001, our significance level probability is 0.05, we can reject the null hypothesis, because your significance value is 0.05, your test results is 0.00, so it is less than 0.05, so that means you can reject null hypothesis. If you reject null hypothesis, you can conclude that mile time or running time for athletic and non-athletic is different. They are the running time or mean running time of athletic and mean running time for non-athletic is different, not similar, right? So that is the conclusion we can obtain. Another thing is you can tell the average mile time for athlete was 2 minutes and 15 seconds faster than the average mile time for non-athlete. Here you can see it in the results graph. Here mean difference of this mean difference has been obtained from non-athlete minus athlete. So here you can take 2 minutes and 14 seconds is higher, faster than the average mile time for non-athletes. Normally, athletes are more faster, 2 minutes and 50 seconds faster than non-athletes. So that is the conclusion that you can come from this two sample t-test. Normally in two sample t-test, I will summarize once again. We used is to use this test if there is two independent sample. If you want to compare two means of two groups, or if you want to compare the interpretation, two interventions after introduction, after doing intervention, you want to compare before intervention and after intervention result, you can go for independent two sample t-test. So next t-test is paired t-test. So pair sample t-test. Normally, pair sample t-test, known as dependent t-test or repeated measures t-test. Uh, Normally, we use pair sample t-test uh, uh, this way to compare the means from same or related group difference. If same groups or related groups, if those samples are not dependent, independent groups, uh, we go for this. For example, if this sample, we have two samples, but those samples are paired, they are dependent each other. In that case, you have to go for pair sample t-test. For example, measurements taken at two different times, pre-test and post-test. If you are conducting, you have one nursing group, you do pre-test and post-test to check their knowledge level on infection control. So pre-test and post-test we conducted to same sample, so we call that is paired sample. And another example is a measurement taken under two different conditions, completing a test under control and experimental. In labs, you can most of scientists conduct experiments using control and experiments. In that case, also we use pairs sample t-test to compare means. In this type of sorry, this two sample t-test, not the two sample t-test, this should be pair sample t-test, right? Sorry, I have written in wrong way, this should be paired sample t-test. uh, T-test. Normally, you need to complete this assumption before running pair sample t-test. Always, the variable should be dependent and normal distributed. There shouldn't be any outliers. And how to write the hypothesis for paired t-test, same as previous one. You need to write hypothesis both null and alternative. Then hypothesis can be expressed in two ways: express the same idea and the mathematically equal. The paired population means are equal or not equal. So you can use either first one or second one. So how to calculate? You can use this formula to if you do hand calculation to take t value. This is my problem statement. A sample data set has placement test score. Placement test has been done to write out of 100 points for four subject areas: English, reading, maths and writing. So the researchers is interested in English and maths section. So he want to determine whether English and maths had higher test score on average. He want to check whether English or maths, which subject has having higher value, right? So we could use pair t-test to test if there was significant difference in average of two tests. Normally same sample is taken here, only one sample, one is student. So the researcher has done placement test to check his English and mathematical level. So he want to find out whether there's any difference between score of English and mathematics. So this is how I am running the t-test. So when I'm doing practical session, I will teach you how to run the t-test in spaces. uh, After running the test, these are the results that I obtained. First table I got is descriptive statistic, the mean value for English, the mean value for mathematics, right? The sample size, the paired sample correlation. So as this is paired sample, as both the sample has relationship, you need to find out what is the relationship between maths and English. So here the relationship is 0.23, and the significant value is probability value, it is 0.00. The pair sample statistic output reveals what we examined before we ran the test. The pair sample correlation table as the information English and math scores are significantly positively correlated, because this English and math should be significantly correlated. There is relationship between English and maths, right? That is why that is how we interpret this one. And this is the second table. So you need to interpret this results, English and maths. Though the researcher want to check whether the mean value of English and maths is different, right? So here your significance value is less than 0.05. This value is 0.00. So you have to reject null hypothesis, right? So your null hypothesis is here. This way, the paired populations means are equal. If you reject this one, you have to go for the paired population means are not equal. That means in your example, the significance value is less than 0.05. So you are, if you reject null hypothesis, the mean values are for English and maths is not equal. So the difference is here you can take the standard deviation error mean is 74.30. Decision. From the results, we can say that English and math scores were weakly and positively correlated. In first table, I told you that it is correlated, and there was significant average difference between English and math. As I told you, that we have to reject null hypothesis because value is very less. And other thing we can conclude is the English score were 17.3 point higher than math score. So that is how we interpret our results. Because the count 17.3, this is the mean difference of two means, right? English and maths, if you can English and maths difference is 17.3. That is why we can come to conclude this way that average English score was 17.3 points higher than maths score. So it is very clear that there is difference between English and maths level means. And it's time for questions. I think it is clear. If not clear, you can ask. Hello? Is that clear or am I need to repeat it again?
Hello, Miss Nadeesha. Again, I am Himali.
Yes, Himali miss.
Hello.
Yes.
When we are writing the alternative hypothesis and null hypothesis, can
Yes.
we write the same concept as yes and no in above and below?
Writing yes and no. Is that
It
is
kind
it?
of no. To write the hypothesis, alternative hypothesis and null hypothesis, can we
Yes.
use the same concept? There is a relationship with two different variables and there is no relationship with two different variables. The
Yeah,
variables are same.
yes, you can use that way also.
Okay.
But in here in t-test,
Yeah.
we are comparing two means always. So then
Okay.
you have to write using means, not variables,
Okay.
not relationship. You are using. If you go for relationship, you can't use t-test, right? In
Yes.
t-test, you have to always write mean difference. Whether there is any difference between means, so there is no difference in between means. That is how in you are writing t-test, right? Yeah.
Yeah.
If you use correlation, you can write that way. There is significant
Okay.
relationship.
Ah, thank you.
Okay. Always Miss Himali is having questions. What about others? Okay, it's time for questions. As you have no questions, I will talk about one common questions most of will be asked. What type of t-test should I use? Normally, this is very common questions most of students ask. When using a t-test, you will need to consider two things. Whether the group being compared come from single population or different population. whether your sample, the sample you take in from one population or two population, right? Other thing is one sample, two sample or paired t-test. It is this way. If the groups come from single population, measuring before and after experimental treatment, you have to go for paired t-test. If the groups come from different populations, two different species, two different cities, or two different sets, you have to go for independent t-test. If there is one group being compared again standard value, comparing, for example, comparing the acidity of liquid to a neutral level of pH. Perform one sample t-test. Always we use one sample t-test to compare and compare with the standard value. Uh, Always there is another question: how to check whether it is one-tailed or two-tailed test? If you only care whether the two populations are different from one another, perform two-tailed test. If you want to know whether population is greater than or less than, you have to go for one-tailed test. That is how one-tailed and two-tailed is explained. So I think it is clear. If not clear, please go through slides and go through the examples. Then you can identify, you can clearly understand. So this is the end of t-test lecture. If you have any question, please ask. If not, I'm going for practical session. Mm. If you can't ask, please write any comment or any chat so I can read and give answers. This is the end of lecture on t-test. I will summarize the lecture once again. Normally in t-test, we have three types: one sample t-test, two sample, and paired t-test. All these three t-tests, about t-tests, you should be aware very well, because when you are running, most of research use t-tests to find their to some analyze their data.